We're going to discuss reactions that involve alkanes, alkenes, and alkynes. So we'll start with reactions with alkanes. If we look at alkanes, they're not very reactive at low temperatures. But at high temperatures, alkanes combust. And we've seen combustion reactions before. So let's say we've got butane and it combusts in air. Okay, so we want to write out and balance the equation. So we know that but means we've got how many carbons? 4, all right? And we've got a saturated hydrocarbon, which means the general formula is CnH2n plus 2. So if N equals 4 for butane, H is going to be 2 times 4 plus 2, or 10. When it says combust in air, it really means that it's reacting with the oxygen gas in the air. And we should remember that combustion reactions produce 2 products, water and carbon dioxide. So when we go to balance this, we've got 4 carbons here, so we'll need to put a 4 here. We've got 10 hydrogens, so 2 times 5 will give us 10. And then we've got 5 plus 8, which gives us 13, and that's an odd number. We can't put a coefficient here that's a whole number to give us an odd number. So we're going to multiply this by 2, this by 2, and this by 2. So we've got 2 times 4, 8 carbons, 2 times 10, 20 hydrogens, 10 times 2, 20 hydrogens. And now we've got 10 plus 16, or 26 oxygens, which we can balance out by putting a 13. So alkanes at high temperatures combust. We need to be able to write the formula for the alkane and then react it with oxygen to produce water and carbon dioxide. So the next thing we want to deal with are what are called substitution reactions. And the name kind of tells you what we're doing. We're going to be looking at an organic compound and we're going to substitute one or more of the hydrogens for some other type of atom. So if we look at the general formula for a substitution reaction, okay, we've got our organic compound here. We're going to react it with some diatomic molecule, and we're going to replace this diatomic molecule for the hydrogen, kind of a replacement here, and we're going to produce that hydrocarbon chain. The hydrogen's been replaced with an X, and then the hydrogen is going to react with the other X. So if we look at a specific example, and I'll actually draw out the structural formula for this, we've got 1 carbon here, so think about what the name for that would be. Okay, so 1 means meth, so this is methane, and our structure would look like this. We're going to draw in the hydrogens just so that we can show the substitution of the hydrogens. We're going to react it with chlorine. We know that halogens make a single bond because they've got these lone electrons around them. And what's going to happen is one of these chlorines is going to replace or be substituted for one of these hydrogens. So we're going to produce CH3Cl. The hydrogen that we removed off of here is going to combine with the other chlorine and produce HCl. And we'll put those lone pairs of electrons on there just so that we finish out our structure. And we would call this chloromethane. Now, the next thing we want to deal with is what's called a dehydrogenation reaction. And when we look at a dehydrogenation reaction, what we're going to be doing are the hydrogen atoms are going to be removed, and they're going to be replaced not with other atoms, but they're going to be replaced with a double bond or a triple bond. So we're dealing with going from a saturated hydrocarbon to an unsaturated hydrocarbon. So we've got an example here. Okay, we've got 2 carbons, and we've got 1, 2, 3, 4, 5, 6 hydrogens. We want to be able to name that. So if we think about it, we've got 2 carbons and it's a saturated hydrocarbon. So you got to put together the prefix for 2 and the suffix for saturated hydrocarbon. Okay, so that would be butane. And what we're going to do is we're going to remove 2 of these hydrogens, a dehydrogenation, which literally means removing hydrogens. And instead of replacing them with other atoms, we're going to have our 2 carbons. We're going to have 1, 2 hydrogens, and 1, 2 hydrogens. But now, by removing those 2 hydrogens, these carbons aren't stable. They only have 1, 2, 3 bonds. So we'll put in that double bond to make the carbon stable. And now we've gone from a saturated hydrocarbon to an unsaturated hydrocarbon. The 2 hydrogens that we removed are going to bond together and produce hydrogen gas. So we want to look at some reactions with alkenes. Remember again that alkenes are unsaturated hydrocarbons. We could also look at alkynes, which have triple bonds, and we'd have the same kind of reaction. So we're going to deal with what's called an addition reaction. And the names are kind of self-explanatory. We're going to be adding atoms in. So when we look at addition reactions, we're going to be adding new atoms are going to form single bonds with the carbons after we remove the double, or in some cases, the triple bonds. So let's look at a couple of examples. Okay, so our first example will be a hydrogenation reaction. And that's going to be the opposite of the dehydrogenation reaction we were looking at before. So let's say we've got 1 propene, and we're going to react it with hydrogen gas. All right, so the ENE tells us it's an alkene, which means it's going to have a double bond somewhere along its parent chain. The prop is a prefix for what? 3. Okay, so we're looking at 1, 2, 3. We're going to have a double bond after the first carbon. So there's our propene. We're going to have 2 hydrogens here, so carbon has 4 bonds. This carbon has 3 bonds, so we're going to add a hydrogen. And this carbon has 1 bond, so we're going to add in 3 more hydrogens. In a hydrogenation reaction, these 2, or this bond here is going to be replaced with 2 hydrogens. So now we're going to produce propane. We're still going to have 3 carbons, but this time these hydrogens came in, filled the place that was where this double bond was, and we're going to have propane. Another example is called a halogenation reaction, and it's very similar to a hydrogenation reaction, except when we remove that double or triple bond, instead of replacing them with hydrogens, we're going to replace them with halogens. So if we look at this as an example, we're going to have pentene. Pent is 5. 1, 2, 3, 4, 5. We're going to have a double bond after the first carbon, and we'll put in our hydrogen. So we've got 1, 2, 3, 4. Oh, that's too many. No, that's good. 1, 2. We'll put 2 here, and we'll put 3 here. What's going to happen this time is we're going to react it with bromine. And we have to remember that bromine is diatomic. So this double bond is going to become a single bond. Each of the carbons now are only going to have 3 bonds, so we have to add something in to make the carbon stable. And this time we're going to add in bromine. So we've got pentane, 1, 2, 3, 4, 5. And we're going to have, after the first carbon, or on the first carbon, we're going to have a bromine. After the second carbon, or on the second carbon, we're going to have a bromine. So we replaced this double bond with 2 bromines, and then we'll have those hydrogens on there. So that'll give us a saturated hydrocarbon where the double bond was replaced with our halogens.